Hi everybody, and I'm posting a very important concept, modulus using the number line technique. And I'm posting this with, where my subscriber count is quite low. If you could do your bit to make this a bit popular or viral, that will be great. All you need to do is hit the subscribe button, in case you haven't subscribed. And if you can like the video and drop in a comment, that seems to, help the YouTube algorithm push the video. Drop in a comment on what you want to hear next from us. That'll be great as well. Or if you like the video, that'll be great as well. Yeah, let's get on to this. Now, what are the values of x that satisfy modulus of x minus 2 equals 5, right? So what does modulus of x minus 2 equals 5 mean? How should we read this? X minus 2 is nothing but the difference of x and 2 plus 2, right? Difference of x and 2. The difference can also be called distance, right? Let's say the distance of x from 2, right? Or you can just say distance of x and 2. The distance of x and 2 is 5. That's it, right? Is 5 equals 5. So what does that mean? How do you do this in the number line? Plot a 2 first, right? Plot the 2 first. What is the distance of 5 from 2? Move 5 units to the right, right? 5 here, 5 units to the right is going to give us 2 plus 5, which is 7. And 5 units to the left, you can only go left or right, right? No other way out on a number line, right? It's a 2D. So 5 units to the left away, in fact, one dimension, right? So left or right only. 2 minus 5 is going to give you a minus 3 over here. That's it. So minus 3 and 7 are the answers. You can try it out quickly if you want. Minus 3 minus 2. Modulus of minus 3 minus 2 is how much? Modulus of minus 5, which works out to a plus 5. What is modulus of the next value? 7 minus 2. That comes to a modulus of plus 5, which is a 5. Now let's quickly take another one. I'm not going to write this down, but what are you supposed to interpret it as? Distance between x and 13. So put a 13 here. Distance between x and 13 is 17. You can move 17 units on the right, right? Or you can move 17 units on the left. That's a minus 17. 13 plus 17 is 30. And 13 minus 17 is minus 4. That's it. The two values are minus 4 and 30. Now, what if you've got a modulus of x plus 2? I said you can use it only if it's x minus of something. Also, remember that the x coefficient should be 1, right? You can't have 2x or 3x, right? We'll see on those, examples of those as well and how to work with them. But right now, it has to be x minus. How do I rewrite it? X minus of minus 2, right? That's an x plus 2. So x minus of minus 2 equals 4. That's it. Distance of x from minus 2 this time around, right? If it's going to be plus 2, you've got to rewrite it. Distance of x from minus 2 is going to be 4 units to the right, 4 units to the left. And what do you get here? Minus 2 minus 4 is minus 6. And minus 2 plus 4 is going to give you plus 2. That's it. The values are minus 6 and 2. Now to one more example quickly. Modulus of x, what do? Rewrite it as minus of minus 5 equals 3. Put a minus 5 there. 3 to the right is minus 2. 3 to the left is minus 5 minus 3, which is minus 8. I'm not writing all of those. So it's just two values, minus 8 and minus 2. Now, what is the question is going to be? What are the values of x that satisfy? Modulus of x minus 4 is less than 3. Very simple, right? Modulus of x minus 4, distance from 4 has to be less than 3. Max can go up to 7, right? 3 units to the right, 3 units to the right. Min can go down to plus 1, right? 3 units to the left. But hold on, does it say less than equal to? No, it's just less than. So it can take any value between 1 and 7. So x over here can be between 1 and 7, not less than equal to. That's the range. Let's take up another one with a plus. Modulus of x, I have to rewrite this, minus of minus 3 is less than equal to 8. So put a minus 3. 8 units to the right is going to be a plus 5. And 8 units to the left is going to be a minus 11. So it's going to be any value between minus 11 and 5. And it's less than equal to over here because this over here has a equal to symbol as well. Now, if you have a greater than symbol, right? Nothing much changes. Distance of x from 2, right? Plus 2 over here has to be more than 6. 6 to the right over here is going to give me a plus 8. 6 to the left is going to give me 2 minus 6, which is a minus 4. Now, what should the distance be from 2? It should be more than 6. It can't be within 6. It has to be more than it, these two regions. Either x is going to be less than minus 4 or x is going to be greater than 8. No equal to symbol because the inequality doesn't have it. Now, let's get into a fun zone with multiple modulus. What is the minimum possible value of modulus of x minus 3 plus modulus of x minus 6? What is this distance from 3? This is distance from 6. That's it. Right? So the sum of the two distances we need to find. So put a 3 first and put a 6 first, a second, right? And how do we look at this? Let us say 3 and 6 are the schools of you and your sibling, a sister or brother, right? You and your sister, let's say. School 1 and school 2, right? You can only go left or right in this particular road. It's on one single road. Your parents are looking for a house so that the sum of the distances covered by the two of you is minimum, right? They want to find a house somewhere on this road so that the total distance traveled by the two of you is minimized. Should they find a house over here and say you travel to this, school 2 is this much distance and here? No, doesn't make sense. Or in this extreme, doesn't make sense. Best over here is find a house anywhere in between 3 and 6. If you find a house anywhere in between, right, need not be the midpoint, right, it can be at 5 as well. What is the distance covered here? 1 unit. Distance covered here, 2 units, right? What is the minimum possible value of this? The distance between 3 and 6. That's it. 1 plus 2, which comes to 3 units. That's it. Think about it. It can be exactly at school 2 or school 1 also. If you find a house right over here, the house is found. Distance to school 1 is 0. Distance to school 2 is going to be 3 units. 0 plus 3 is again going to be 3. So anywhere between 3 and 6, that pretty much satisfies the condition. The value of this, the sum of these two modulus gets minimized. Spend some time, rewind and watch this again if required. Or let's take up another example. Now let's take up an example with, let's make it modulus of x plus 2 plus modulus of x minus 8. What is the minimum possible value of this? X minus of minus 2, right? Put a minus 2. And the other one is going to be distance of x from plus 8. Put a plus 8 over here. That's it, right? What is the reason for the minus of? It was earlier there in the video. In case you forwarded, just go back, right? We should find it. Distance of x from minus 2 is what it is. And when does this get minimized? When you find your x value anywhere between minus 2 and 8. Anywhere. Let's say 0 over here. 2 plus 8, which is 10. Or simply the distance between minus 2 and plus 8. What's the distance between minus 2 and plus 8? 8 minus of minus 2, which comes to a plus 10, right? So 10 would be the answer here. Now let's up it further. What if it is how many integer values satisfy modulus of x minus 6 plus modulus of x plus 2? Immediately rewrite this as x minus of minus 2, right? Is less than equal to plus 12, right? How do we do this? Distance from minus 2, I'll start with that, and distance from plus 6 has to be less than equal to 12. Now, if you find a house anywhere in between, what's the distance over here going to be? 6 to minus 2, 6 minus of minus 2, which comes to plus 8. 8 units is the distance. If you find any house over here, any point over here, the sum of distances is going to be 8. It satisfies the inequality. It's less than equal to 12. Now, how much more is allowed? From 8, I can go up by 4 more units, right? It can be a max of 12. Now, 4 units means, look at it simply, you have to travel double the distance. The extra distance is going to be for both the schools you're going to be traveling for, right? So, therefore, if 8 is the distance over here, 12 is the max you can go for. 12 minus 8, 4 divided by 2. Extra 2 units, extra 2 kilometers you can go to the right. What is the logic again? 12 minus this 8 which is already there, divided by 2 because 2 schools you have to travel to, which comes to 4 by 2, which is 2 kilometers extra, plus or minus allowed, plus 2 and minus 2. So take a value here, plus 2, we bring it to 8. Just check once. Distance here is 2. Distance from 8 to minus 2 is 10. Yes, it satisfies. 10 plus 2 is 12, right? So 10 plus 2 is 12. If you plug in 8 over here, you're going to get 12 exactly. Likewise, you take 2 units to the left over here and you get a minus 4, right? These are your magic values. Plug in a minus 4 here, you'll once again get a 12. It has to be less than equal to 12. Any value between minus 4 to 8 is allowed, right? Minus 4 to 8 is allowed, as it is less than equal to, both are included. So how many integers are there from minus 4 to 8, both included? I've told you a formula. It's a simple formula, y minus x plus 1, right? Y minus x plus 1. If y is the larger value, x is the smaller value, right? What's that going to be? 8 minus of minus 4 plus 1 if both are included, right? Therefore a plus 1. If both are excluded, it's a minus 1. If one included, one excluded, it is simply y minus x, right? It's covered in the number theory lesson. Okay, back to this. 8 plus 4, that's 12. 12 plus 1 is 13. 13 is the answer over here because we're speaking about only integer values. Now let's take up the 10th one. That's an interesting one. I've told you, right? You've got to have a coefficient of 1 for x. You can't have 2. But what can I do over here? If the coefficients of x are the same, I can just divide them by the same value, right? So what do I do over here? Divide this entire thing, left hand side and right hand side, by 2. So what is modulus of 2x minus 10 by 2? You get modulus of x minus 5 plus modulus of x minus 11 for this is less than equal to 20. That's it. Then you do the same. You have 5, you have 11. Distance is 6 over here if you find some place over here. Now, of 20, 20 is the max allowed. Remove the 6, it's already going to be there. And then by 2, because twice you're going to be traveling. 20 minus 6 by 2, that comes to 7 units. You can find a place 7 to the right. 7 to the right of the rightmost. And that's going to give you 11 plus 7, 18. And 7 to the left over here. And 5 minus 7 is going to give us minus 2. Now the question over here is simply the sum of the smallest and largest values. Smallest and largest, what's the sum? Minus 2 plus 18, which comes to 16. That's the answer here. Now what if the question is going to be, what is the sum of the smallest and largest integer values of x that satisfy this? Once again, put a 2, put a 7, right? We should be quick right now. And the distance here is 5 units. And 12 is the max allowed. 12 minus 5 divided by 2, that's going to give you 3.5. Plus 3.5, you can go up to 10.5. Minus 3.5, you can come to minus 1.5. And in this range, what is the smallest and largest integers? Smallest integer in this range is minus 1. The largest integer less than 10.5 is going to be 10. What is the sum of this? Minus 1 plus 10. That's going to give us 9. 9 is the answer here. Now on to the last example before we move to CAT questions, right? What are the values of x that satisfy modulus of x minus 20 is less than modulus of x minus 40, right? You have it on two sides of an inequality right now. So distance from 20, so I'll put a 20, is less than the distance from 40. That's how you read it. Distance from 20 is less than distance from 40. When are you going to be equidistant, right? Again, two siblings, right? You and your sister, let's say. School 1 and school 2 you go to. Your parents have to find a house such that both of you travel the same distance. Where do they find the house? At the midpoint over here. What's the average of 20 and 40? That's 30. That's where they find the house on rent or whatever it is, or they buy it. And you're going to be traveling in two directions, 10 to the left and 10 to the right, right? You're equidistant. Now, what are your parents saying? You know what? They are favoring a particular kid. They're saying the kid traveling to school 1, the distance to school 1, let it be less than the distance to school 2, from school 2, right? 40. Let this distance be, let's find a house which is closer to school 1. Distance from 20, right? Should be lower. So that's it. Find the midpoint, the region to the left. Any point if you find here, it's going to be closer to 20 than to 40. is going to be closer to 20 than to 40. That's it. So what are the values of x that satisfy this? All values where x is less than 30 satisfy it. Now what are the CAT questions? CAT 2021 slot 1. The number of integers n that satisfy the inequalities, modulus of n minus 60 less than another modulus, which in turn is less than another modulus. The earlier example we saw only 2. How do we look at this? There are 2 inequalities over here and that's it, right? So what are my 2 inequalities? The first inequality is over here, which I shall map in this number line. The second inequality is over here. Modulus of n minus 100 is less than modulus of n minus 20, for which I'll want another number line. So let's draw that below, right? For the first one, all I need to do is put a 60 here and put a 100 here, right? And what do? I want the distance from 60 is less than distance from 100. Midpoint over here, 80, right? And what are the values I want? I want it to be closer to 60, right? So I want this region. What about the next inequality in the other number line? Distance from 100 is less than distance from 20. So let's put 100. Let's put a 20. What's the midpoint over here? 20 and 100. Average over here is nothing but 60. Right? 60. And which region do you want? You want it to be closer to 100. Right? Distance from 100 is less. So I want this region. That's it. So what are the integer values which satisfy? Everything between 60 and 80 and less than symbol, not less than equal to. So therefore the formula is y minus x minus 1. Remove 1, right? If both are excluded. 60 and 80 are not to be included. 80 minus 60 minus 1. That comes to 19. That's it. Apply this concept along with this and you answer them so quickly. Now the same year, another slot you got for a real number x, the condition of this is equal to 20 necessarily holds if, okay, all I need to do over here is divide the entire thing by 3, the left and right, right? Why do I have to do that? We discussed earlier, the coefficient of x has to be 1. So how do I rewrite this? Modulus of x minus 20 by 3, right? Okay, plus modulus of x minus 40 by 3 equals 20 by 3. So distance from 20 by 3 and distance from 40 by 3, the sum of these two should be 20 by 3. Now think about it. This will happen only if I find a point over here in between. So what is the sum of the two distances? The distance between these two. 40 by 3 minus 20 by 3 is the 20 by 3 which I need over here. The sum of the distance from 20 by 3 and 40 by 3 should be 20 by 3. That happens only if the point is between these two, right? Between these two, because the difference between the two values is 20 by 3. So I need to find a house over here between these two. That's it. 20 by 3. Now the best way to go about this, write it as a mixed fraction. 6 2 by 3, and over here 40 by 3 is nothing but 13 1 by 3. Now this one says necessarily holds if the first one is true. Can I say as long as x is greater than 6, this is satisfied? No, x has to be greater than 6 2 by 3. 6 is not enough, right? Not enough. Can I say that if it's between 9 and 14, it's fine? More than 9 is fine, but less than 14? No, between 13 1 by 3 and 14 is not satisfying, right? It has to be, the inequality has to be within this region, right, for it to be a definite tick. 10 to 15, 15 is going outside of this. That's not allowed. 13 1 by 3 to 15 is going to be not allowed. 7 to 12. Is 7 to 12 perfectly fitting within this? Yes, 7 to 12 is coming exactly over here. Satisfies. Option 4 is the correct answer here. Now the next year, CAT 2022, they asked a fun question. The largest real value of A, for which this equation modulus of x plus a plus modulus of x minus 1 equals to, has an infinite number of solutions for x. Now remember this, you will have an infinite number of solutions only if it is going to be, let's say, the distance, if you have to find a house between 2 and 4, and the distance total is going to be 2. Modulus of x minus 2 plus modulus of x minus 4 equals 2 means infinite solutions. If it's going to be equal to 4, there are only 2 solutions, right? Extra 2, distance between 2 and 4 is 2. There's an extra 2 which has to be divided by 2, 1 unit. So only 2 units satisfy, one to the left, one to the right, and one to the left, 1. Plug in. Only 1 and 5 when substituted. 1 minus 2 and 1 minus 4 will add up to 4. And 5 minus 2 and 5 minus 4 will, the modulus of those will come to a total of 4. No other value. So what is happening over here? You will get infinite number of solutions only if it's going to be within this. That means I want the sum if it's going to be 2 and let's say 8, right? If I want to find anything in between which satisfies, I have to form it as modulus of x minus 2 plus modulus of x minus 8 equals 6. 6 units is going to be the total length. So I can find a house anywhere over here, right? Distance from here and here, it's going to add up to 6, right? Distance from here to here and here, it's going to add up to 6 if x is here. So infinite solutions because infinite points between 2 and 8. So back to this question, what are they saying? Distance from A plus distance from 1. Now, is it distance from A? Actually not. It is distance from minus A. Yeah, we got to be careful over here. Plus has been used. So distance from minus A and distance from minus 1 equals 2 has infinite solutions, which means this is a part where it might be tough for some of you. You have to rewind and watch this and think about this concept again. From 1, I want to be at a distance of 2, the A value, or rather the minus A value. Either I can have a 2 units to the right over here, which is going to be 3, can be minus A, or 2 units to the left over here, which is minus 1 could be A, right? So, which is minus A, once again, right? Let's not make a mistake. Distance of x from minus A. So if minus A is equal to minus 1, then A equals 1. If minus A equals 3, then A is minus 3. What are they asking? They're asking us for the largest real value of A. Between 1 and minus 3, the largest real value over here is plus 1. A lot of scope for silly mistakes with these options over here. People might go for minus 1 as well. You've got to be careful and clear with the concepts, right? So distance from minus A plus distance from 1 has to be 2. So just pick your 1 and your minus A to be 2 units apart from 1, right? This is the other way around right now. On to question 4. Sum of the possible values of x in the equation. Modulus of x plus 7, right, minus of minus 7 plus modulus of x minus 8 equals 16. So quickly, minus 7 you plot here, 8 you plot here, distance over here is 15, right? And you have extra 1 unit. So 0.5 to the right, 8.5, you can try substituting later, and 0.5 to the left, minus 7.5. Those are the only two x values which satisfy this. If it had been equal to 15, infinite values between minus 7 to 8. But if it's little more than 15, the extra part you divide by 2, that to the right and that to the left, and you get. So what's the sum of minus 7.5 and 8.5? That's plus 1. Option 2 is the answer here. Now, if x satisfies the inequality, modulus of x minus 1 plus modulus of x minus 2 and goes on, it is greater than or equal to 6. Work with the options a bit over here, and we'll take up a few more examples with triple modulus or 4 modulus soon. So distance from 1, distance from 2, and distance from 3, right? So plot 1, 2, and 3 is going to be greater than or equal to 6. I see values like 0, 4, and all of that coming twice. Try out a 0. What is the distance from 0 to 1, 2, and 3? That's 1 plus 2 plus 3 adds up to 6, right? You want it to be greater than or equal to 6. You want it to be beyond 0. Right? Beyond 0, this region is what is accepted. Likewise, where was 0? 1 to the left of 1. Try 1 to the right of 3. You get 4, right? You get 4 over there. Again, 4 minus 3 plus 4 minus 2 plus 4 minus 1 is exactly 6. But you want it to be greater than or equal to 6. You want this region over here, right? Less than or equal to 0 or greater than or equal to 4. Option 2 over here is the answer. Now, as I said, let's up it a few notches. Where f of x equals modulus of x minus 3 plus modulus of x minus 5 plus modulus of x minus 10, what is the minimum possible value of f of x? The sum of the distances from 3, 5, and 10, right? So let's say you have 3 siblings, right? Yourself, a brother, and a sister. Now you're going to 3 schools, school 1, school 2, and school 3. Where should your parents find a house such that the distances traveled are minimized? It definitely has to be between 3 and 10. Why would you go beyond 3, to the left of 3 or to the right of 10? There's a lot of distance to be covered. It has to be between 3 and 10. Find a point now such that distance to school 2 is minimized. Then you find a house very close to school 2 or sitting right on top of school 2. That's your house. That's your x value, where you get the minimum possible value for this. So if you substitute 5 over here, you're going to get modulus of 5 minus 3 plus modulus of 5 minus 5 plus modulus of 5 minus 10, and you're going to get 2 here plus 0 here plus 5 here and say 7. That's one way to find the 7. The other way is to say this sibling is not traveling any distance 0. The distances covered to the left and right are going to total up to 10 minus 3, which comes to 7. Distance here is 0. This total distance to school 1 to school 3 is 7. And that's your 7 over there as well, right? You don't need to substitute in base time. 7 is the answer over here. Another example starts with x minus of minus 1, right? Put a minus 1 there, then 2, then 7. I'm not going to take time right now. You can rewind, watch the previous one. What is the minimum possible value of f of x? At x value of 2, it's going to sit over here, right? That's when the distances are minimized. 0 here and minimum to the others. The total distance covered is nothing but 7 minus of minus 1, which is going to be 8. Answer is 8, right? F of 2 gives you a value of 8. That's when it attains minimum. Okay, just a couple more questions. What if you make it 4 modulus? Right? Let's plot it. 2, 5, 10, and 18. You've got to find a house, 4 schools. I'm not going to write down the school names. Now, it has to be between, your values have to be between 2 and 18 for it to be minimum, for sure. It also has to be between 5 and 10. Alright? What is the range of x which satisfies over here? Where x is going to be between, alright, 5 and 10. Any value you find over there, that's going to satisfy. Right? You can plug in over here, you can find the distances. But what is the f of x value going to be? Right? In this, anything you plug over here, what is the range, what is the sum of all of this going to be? You do the substitution. I'm not going to spend time there. You can substitute 7 or 8, but your answer is always going to be the minimum, right? If you're picking anything between 5 and 10, your x value over here, right? X value is going to be in this range. The distance from 5 to 10 has to be covered. So that's 5 units. Somebody has to go to 5 and 10. Also, somebody has to go to 2 and 18. 18 to 2, that's 16 units. So f of x is going to be 5 plus the 16. This 5 plus 16, total distance covered. 21 is the answer over here for the f of x value. And for x value, it's going to be this. Now, what if you have 5 modulus? Let's up it further. 2, 5, 10, 18, 25. You need it between 2 and 25. You need to find the x value between that to make it minimum. The next two values, 5 and 18, it has to be between that as well, the next two edges. And you just have left with 1. If it's an odd number, you have to make sure your x value is sitting over here so that distance is 0 from 10. That's it. So at an x value of 10, it attains minimum. And what is f of 10 going to be? I'm not going to do the substitution over here and waste time. 18 to 5 distances, 18 minus 5, which is 13. 25 to 2, the distance is 23 units, 25 minus 2. 13 plus 23 is the answer. That comes to 36. X is 10 and f of 10 is 36. So super fun, wasn't it? Now let's look at a CAT 2003 question which turned up. Something like this, what is expected. Modulus of x minus 2 plus modulus of 2.5 minus x. You can always, within the modulus, you can multiply with a minus 1, nothing changes. X minus 2.5, you can write it as plus modulus of x minus 3.6. And you have a modulus of x minus 2. So distance from 2 and distance of 2.5 and distance from 3.6. If you add these up, right, has to be minimum. When is this going to be minimum? The distances between 2 and 3.6, you have to find a value. There's only one more value left. It has to be sitting on top of it, x. This is what we saw earlier. So x equals 2.5 is the answer. And that's it. If you understand these concepts clearly, you should be able to answer these questions in very little time. And these are actually tough questions conceptually, right? Until you understand the concept. Once you're clear with it, you're going to be answering it very, very quickly. Continue your prep. I'll see you in the next video.